Okay, in this lesson, quick little short lesson, because we're going to introduce the conventions that are used. They're familiar conventions to us. The only thing we're going to introduce new in terms of language is this notion of Lenz's law. Lenz is honored with this law of the restorative aspect of the induced voltage. So the negative that appears, as we've said, in the induced voltage equation. So as the flux changes through a coil, the magnetic flux changes, an induced voltage is produced, which makes an induced current, which produces an induced B field to fight the effect that's causing it. Just like, once again, one last time, Hooke's law, the spring force is a restorative force fighting the effect that causes the force to be produced. When X produces the force, the spring says, I don't like this. I want to go back to zero. When the flux changes with respect to time, that's what produces the E-induced, which says, nope, I don't like this. I want to go back to status quo, back to where we were. Well, the conventions we use are the same Cartesian coordinate conventions, where out of the paper is going to be our positive z-hat direction. That's going to be positive, so B field coming out of the paper is positive. B field going into the paper is negative. If we can, whenever possible, when possible, we will work within the plane of the page so that we are facing the circuit, and those are our B field conventions, positive towards us, negative away from us. Back when we introduced rotational motion, we identified counterclockwise as positive. So the omega vector, if you recall, counterclockwise was positive, and the convention was the right-hand curl. So if you think of the plane of the page, the motion in the plane of the page, the EMF being directed clockwise or counterclockwise, within the plane of the page, we're going to take our right-hand curl. So we're going to put our palm perpendicular to the page, our pinky down. When we curl our fingers and make a fist, that counterclockwise motion of our fingers puts a thumb up, positive direction. Clockwise would be that reverse karate chop. Our palm is again perpendicular to the page, but we have to kind of contort. Our palm is perpendicular. We curl and make our fist. That's a thumb into the paper. So those conventions are very familiar to us. Lenz's law, if you see that in a multiple choice question, it will be more of a multiple choice concept than a numerical calculation. The negative appears in the numerical calculation, but the reference to Lenz's law is specifically that the induced current, the induced voltage, the induced B field, all is produced in such a way that it will oppose the change that produced it. So you definitely need to associate that with Lenz's law. Now, to look at the two possible scenarios before we actually go to our numerical example in our next lesson, is to just again remind ourselves of what's going on here and to make the analysis conceptually without any mathematics using Lenz's law to understand the induced current being clockwise, counterclockwise, and the induced B field that it makes. So the example we used, just to go back and remind ourselves on the first page of notes, was the example over here where we were moving the magnet towards the loop area, increasing the B field that was crossing that pink area. So the flux was increasing, and if it helps you, actually count it out. Say the B field through that pink area, right, is going from 10 to 11 to 12, and nature wants to stop that. So it's 10, right? It's 10 up, but now it's getting stronger. It's 11, and now it's going upward. It's 12. Well, nature is going to create a B field, B induced, to try to keep that from happening, from getting bigger and then bigger still. So I induced is going to be in this clockwise sense with B induced down to try and fight that from happening. And we have the same thing if the B induced was getting smaller. So through the pink area, if that B induced was 10 down, but then was going to, up. Erase it. The B field is still going up. So if the B field is up and it is 10, but then it's still up, but 9, and then it's still up, but 8. So nature will want to stop that from happening. So it's going to make B induced up to try and keep the magnetic field going up and remaining large. So B induced up is made by I induced, which in this case is going to run counterclockwise. And when you do your curl IDL across R hat into the center of the loop, your B induced is up. So you want to get used to doing a conceptual analysis. Use your conceptual analysis to get the induced current and the induced B field correct without having to rely on just the numerical conventions and hope that you didn't, lose a negative along the way and end up with the wrong answer. You know you will have the right answer if you'll follow Lenz's law and do it conceptually up front in the problem.